Hello dear students, today we are going to learn about a new device, that is torch. What is a torch? All of you might have seen a torch at home, right? And have you seen how does it work? First let us see what is a torch. A torch is a portable. Portable means what? Which can be carried from one place to another. Portable electric lamp, which uses two or more cells or batteries to light up the bulb. Means with the help of cells, we light a bulb and we carry it to place from place to place wherever we need light. Now a torch is used to provide light whenever we are going out during the dark night, or sometimes at home when there is no electricity supply fails. Okay, when electricity supply fails, that is when there is no electricity supply, then we use a torch. Now nowadays you might have seen different types of chargeable torches and are all available, but the basic in olden time or even now we are using it, torches are working with the help of two or more cells. Okay, the torch has some parts that you have to learn today, the structure of a torch. Now see here there is a cell, okay, sorry, here there is a bulb, and here there is a reflector. Okay, what is a reflector? Whenever the light falls on it, that light will be reflected. Reflection you know already. And here there is a transparent glass through which it will come out. Now inside the this torch you have two cells. Now if you see this bulb, its metallic end is touching the positive side of positive terminal of one cell, and its negative terminal, the cell's negative terminal is attached to another cell's positive terminal, and again its negative terminal is attached to a metallic strip, a spring like structure here. Why do we have a spring here? When you tightly close the torch, then it will not lose its contact. Okay, when you have a spring, it will just get some compressed and it will get connected. Okay, and then this string, metallic spring like portion, it is connected to a switch here, sliding switch. It can be moved up and down, and from this also it is connected to the bulb, also is connected to the switch. Okay, now you see here when you can slide means this switch can be moved up and down. So when it is moved up, it is touching both the terminals of the connecting wires are attached to it. So there is no gap between there is no gap in the circuit. So here you see here the complete circuit is connected. This is the source of electricity, this is the upline, the bulb, and this is the switch, and these two are the conducting wires. You see here from the cell it is connected to the bulb, from the bulb it is connected to the switch, from the switch it is connected to the cell again. So it is a complete circuit. So when you move this up, these two wires are connected and it is a closed circuit. So what happens? Electricity flows from the cell to the bulb, and the bulb starts glowing, and the little bit only, and that glow of light is reflected through the reflected through the reflector, and it is passed on through the transparent glass sheet. Okay, now when you don't want it, the benefit of this torch is that when we don't want, you can just slide it down, switch off. So what happens when you move this switch down, here there will be a gap. Okay, so what happens here, there will be a gap, and then the flow of electricity will be disturbed, or it will be broken, so there will be no electricity, flow of electricity, so the bulb will not glow. Okay, so this is a torch which is used whenever there is darkness, when there is no light, no electricity, when it is night, when you want to go out, then we can use it. Now see, this is in the off position. You see here the torch is turned off. Again the same torch is here, and this is the circuit. Here it is connected, here also it is connected, there is no problem. But here you see the switch is slide down, that is in the off position, creating a gap here. So this gap, due to this gap, this circuit is not completed or it is open. So what happens? There will be no flow of electricity. So the bulb will not glow. Okay. Now, when we are not using this torch, when we don't want to use it, so what we do is, you take open from here, it will be, you can open from here also, but usually we open here, and only when the bulb is fused we open from here to remove the bulb. Okay, so here when you open, what they do is this, they take these two cells, and here it is touching the positive side. What they will do, this negative side will be connected to the other negative side, so there will be no chance of flow of electricity. So unwanted wastage of energy can be saved if you reverse the cells and keep it. Okay, otherwise what happen, if you use it or not, flow of electricity will be there, and this leakage will be there. Okay, leakage of power will be there. So to avoid that, when you are not using the torch, you need to keep it reverse. I mean the cells should be kept reverse. Okay, and sometimes you might have seen on olden times, sometimes when the spring loses its power, it is not tightly closing, people will keep a coin here. Why not a plastic piece? Why do they keep a coin? Do you know? Because coin is a good conductor of electricity. Okay, now we will learn about what are good conductors and what are bad conductors or poor conductors or insulators of electricity. As you learned in light chapter, transparent, translucent and all, here also we have terms for materials which allow light or electricity to pass through them. We learned about light in the previous chapter. Today we will learn about the materials which allow electricity to pass through them are called conductors of electricity. What are they called? Conductors. And which do not allow, they are called insulators. Okay. Now these conductors, usually if you see, most of the metals are good conductors of electricity. Conductors are mostly metals, and most of the non-metals are insulators. Okay. So those materials which allow electric current to pass through them are called conductors of electricity. Okay. What is electric current? Flow of electric charges. Okay. And flow of electric current is called electricity. So some of them will allow the electricity to flow through them, and they are called conductors. Okay. And all the metals are conductors of electricity. The best conductor is silver, and copper, aluminium metals are also good conductors. So that is why in our house electric wires are made up of copper and aluminium. Why they are not made up of silver? Because silver is little costly. Other metals like iron, steel, mercury, gold, all these are good conductors. But usually in electric wires and all we use copper and aluminium. Almost all the metals made up of all the objects made up of metals or even alloys. What is alloy? combination of two or more metals are also conductors. The objects such as coins, coins, keys, pins, aluminium foil, swing needle, all these are examples of conductors. There is one non-metal which is a very good conductor of electricity, that is carbon. Carbon form, that is graphite. Graphite means your pencil lid is there, no, that one. The thin black core of pencils which we are there in the pencil lid, it is graphite, and it is a good conductor of electricity. Human body does not conduct electricity as good as metals, but human body also can conduct some amount of electricity. So it is not called a conductor, but it is a poor conductor of electricity. But a person, if you get electric shock on touching an uncovered electric wire carrying current, because some electric current passes through his body. It is not like and not only that, there will be some metallic things in our body, then you get more shock. Okay, when you touch electric wires or anything with open wires with hands, or by mistake also if you touch, you will get shock. And one more problem is that when your hands or legs are wet, you get the flow of electricity will be faster in your body. Water, pure water, that is rainwater, which you get is distilled water, which is a poor conductor of electricity. But if any impurities are there in water, it will become a conductor. Okay, so we should take care while dealing with electricity. See, electricity is too useful to us, at the same time it can be very dangerous also if not taken care. Okay, now the materials which do not allow electric current to pass through them are called insulators. Almost all non-metals are insulators. Plastic, PVC or bakelite, ceramic, this porcelain, asbestos, wood, glass, all these are cotton, jute, thermocol, wax, paper, air, all these are insulators of electricity. They do not allow electricity to pass through them. Now, if you make things with the help of insulators also, they will become insulators only. For example, if you erase with rubber, right? Rubber is an insulator. Similarly, balloons are insulators. Have you seen the handles of cooker or saucepan and all? They are made up of bakelite. They are also, or wood some places. So they are also insulators. Okay. Also the outer covering of the wire. The wires are never kept open. It is always covered with plastic, which is a insulator to avoid short circuit or electric shock due to conduction of electricity. Air is also an insulator. Okay, air is a poor conductor or is an insulator. That is why when electricity is passing through the air, we don't get shock or we don't get any problem. Okay. Now see, for us, insulators and conductors, both of them are of equal importance. We need conductors to take electricity from one place to another, or for working of all the appliances. At the same time, for working of an appliance, we need both insulators and conductors. Switches are made up of insulators. If switches are made up of iron or any conductors, we won't be able to operate it. So both conductors and insulators are of equal importance. Okay. Um, Similarly, if air is a conductor, you won't be able to survive or you won't be able to use electricity. Okay. So both conductors and insulators are of equal importance. Okay. uh, I told you, this electric cookers, electric heaters, all these are using their handles of sorry, backlight or any such wood to avoid shock. Okay, so have you seen these electric heaters, which is used to boil water when you want to take bath? Hot water, to make hot water, there is a coil connected to a wire, and the end handle is made up of wood. Just plug in and switch on it, keep it in water, so it will heat the water. Okay, so there are many instruments which we use, or many devices which we use, which work with electricity, and devices are made up of um, conductors, and they are covered with insulators. So both conductors as well as insulators are of equal importance for us. That's all for today. With this topic, the chapter gets over. In the next class, we will discuss the textual exercises and the notes. Thank you.